listening to Everyday Evidence, presented by the American Occupational Therapy Association, helping the occupational therapy practitioner apply evidence to practice. Here's your host, Matt Brandenburg.
All right, welcome to the show. I am your host, Matt Brandenburg, and today we are joined by Bill Janes. We're going to be discussing his expertise in assistive technology and 3D printing. Bill, thank you so much for taking the time to join us on the show and share some of your areas of expertise with us.
Thank you, Matt. I am thrilled to be here.
Good. That makes two of us. We've got two people thrilled today. Hopefully our listeners are just as thrilled as we are. Bill, what motivated you to focus your scholarship and professional efforts on assistive technology?
Oh boy, it's kind of a personal journey. I started my academic career as a professional researcher in 2011 when I finished up my OTD and in NIH fellowship, and then went on to faculty at Washington University. Great institution, great mentorship and support, but I was doing work that just wasn't what I wanted to do, and got some really good career advice from my mentor at the time, Jack Angsberg, who asked me, kind of a cliche, obvious question, but it was, what part of all of this work do you enjoy? And I'm a big nerd. The technology stuff was the stuff that was fun for me, whether it was assistive technology or in the rehabilitation context or even ed tech. And so Jack helped me really think about where the intersections of that technology interest and OT were, and encouraged me to focus my work there. So I took his advice and just kind of shifted my whole trajectory from there into assistive technology and the part where I could really get my hands dirty trying to make AT.
I love that. I think it's so important to enjoy what we do as occupational therapy practitioners. And I thank you for sharing that story. Hopefully our listeners are inspired to do the same, to remember to make room for the things that you enjoy and you're interested in your day-to-day, and share that passion with our clients. Bill, why do you believe it's important for OTs to get involved in creating assistive technology?
I don't know that it always is, but I think OT practitioners have this skill set all around task analysis. We're really well qualified and trained to identify those mismatches between the person, the environment, the occupation that people are trying to do, and their performance of it. If you can't tell, I was raised in PEOP by Carolyn Baum. And so I think that's where our skill set really, exists. And AT is typically there to bridge that gap between the environment, the task that the person is trying to do, or the occupation, and the person's own individual abilities. So AT, or assistive technology, is just one possible approach to addressing those kind of gaps, but it's the one where I feel comfortable. And I think AT historically, like most technologies, is designed first by engineers and designers. And they have a really great, useful skill set too that we don't always have. And they do a great job of identifying performance gaps, identifying the demands and constraints of any given task, but they don't always have that full picture of what goes into occupational performance that an OT practitioner does. So when an engineer designs a device alone, you get a really good purpose-driven device, but it doesn't always fit that individual's life. It doesn't fit all of the context and the environment that they're doing things in, or their other needs. So I think when you combine that OT perspective with more of the engineering design approach, you get the best possible outcomes. And when you keep the client, the user of the device, at the center of that whole process, you get a device that helps to bridge those PEOP gaps to maximize performance in the end.
And I love that. Bringing PEOP to all areas of practice is something I support, being a PEOP trained and educated practitioner as well. I think it can be so impactful, like you mentioned, collaborating with engineers and designers to bring that kind of person-centered and client-centered focus and approach to performance and applications of AT. How does 3D printing really intersect with OT practice and enhance assistive technology development?
Yeah. So again, I'll kind of couch this by saying it doesn't always, but 3D printing is one medium. It's one tool in your toolkit. If assistive technology is one tool in the OT's toolkit, 3D printing is just one small subset of that tool. So from the engineering perspective, they use 3D printing as a verb a lot of the time, meaning rapid prototyping. So 3D printing historically is valuable in that it lets you make materially inexpensive iterative design. So you have an idea, you can make a thing really quickly, check and see if it works. If it doesn't, make quick tweaks and do it again. Whether 3D printing winds up being the medium that is what's going to actually go to production in the end, again, historically in engineering approaches, it's typically not. But the nice thing here from the OT perspective or the non-engineer's perspective is 3D printing is so accessible. You can buy a printer more easily and less expensively than, say, all of the equipment you would need to do something like injection molding to make plastic devices at scale. So it's a relatively inexpensive, easy way to get into this process of making physical devices. But again, a lot of people will never need 3D printing as a medium. A lot of OTs will never need it. Therese Wilkham has these great books and YouTube channel and everything about making devices out of everyday materials. And I'm willing to bet the majority of OT practitioners out there who have been, especially in a school setting or an outpatient setting for any amount of time, have probably made something at some point out of just stuff they had laying around in the clinic because they realized they could meet the needs along with their client. So 3D printing is just another way to do that with a slightly more robust material. And it's also really easily modifiable and replicable. So you can take the designs that you create, easily share them with anyone around the world who, so long as they also have this relatively inexpensive piece of equipment on their desk, they can make the same thing that you've made. So the accessibility from getting started and from replicating and continuing on makes it a real nice approach to assistive technology.
I love that. I love that. It sounds like 3D printing can and has already opened some new doors in terms of accessibility and replicability of assistive technology. I want to share my only exposure to 3D printing. I have a coworker who's a physical therapist, and he loves Dungeons and Dragons, and he uses a 3D printer to print out, character molds and, figurines to use in his tabletop Dungeons and Dragons games, and just can download these templates from online and print them out on his own. And it's a wonderful hobby and occupation that he enjoys. What sparked your interest in 3D printing and using it or applying it to occupational therapy and assistive tech in this way?
Well, not much different than your colleague. I'm a big nerd. I say that with love. No shade on your colleague there. Different type of nerd. I'm not so much into the Dungeons and Dragons side, but the two ways people tend to get into 3D printing are to make tabletop gaming pieces or to make stuff for around their home and to make functional devices. Those are the two most common. So I had been reading tech blogs for years. That's kind of what I do in my free time over lunch. And remember when 3D printing first kind of hit the mainstream as a consumer technology that you could buy in the late 90s, early aughts. And that just happened to parallel with this time where I was really building a lot of interest in assistive technology. And at the time, prosthetics, and thought I saw a really good route there. And just my thinking has evolved from there. So the whole origin of my interest in 3D printing is the fact that I'm a big nerd.
I love that. I love that. And of course, on this show, we always use the word nerd very endearing and in a positive light. We
Absolutely.
support,
It's not a pejorative. I have to remind my students and my own kids of that all the time.
I love that, Bill. Thank you for reminding us of that. What are some of the types of devices you've created or worked on using 3D printing?
Yeah. So when it comes to assistive technology devices, we are really careful in my lab to focus on what are called daily assist devices. What the FDA would call a class 1 device is a daily assist device. So the criteria there are these are things that are not intended for supporting or sustaining life. They don't present unreasonable risk of injury or illness, and generally nothing that would go inside of the body. A big part of the reason for this is liability. I don't want to expose myself to the liability and the risk, even for my client, of designing a device that would keep them alive and have that device fail. You always have to think about the fail state of the design or the thing that you're making. When it breaks, not if, but when it eventually fails, what's going to be the result of that failure? So the starting point is always existing devices. We start by scouring existing repositories. Makers Making Change is a great nonprofit out of Canada that has entire catalogs of assistive devices that are 3D printable or can be made through other media that are open source. Anyone can download these instructions and make things. Most of those are these daily assist devices. So things like nail clipper adapters are probably the most popular thing. Writing tools are very popular. Key guards are very popular in this space. You can get most of these designs from Makers Making Change directly, but there are also repositories like Thingiverse, which are intended for all kinds of 3D printing designs, your tabletop game pieces, your functional stuff for at home, but also a lot of AT gets posted there. So we always start with those designs and then modify or make our own. So we've modified existing designs for a tube roller, like for the toothpaste tube to help squeeze out your toothpaste, that nail clipper adapter from Makers Making Change, key turners, all of these pre-existing designs that when I say we, I typically mean students in my lab, either OT students or engineering students, have found clever ways to tweak those based on the needs of our individual clients here. And then they've also designed some new devices. I have to give most of the credit here to Ariana Kionmer, who was an engineering student in the lab that came up with really neat, clever devices for holding a guitar pick for a guitar player with some difficulty using his fingers and hands, button hooks, Q-tip holders, a paintbrush holder that used a really neat collet design that she came up with, and magnets for fastening things together. We've designed a foot support for a woman who had ALS who wanted to paint using her foot but could no longer kind of support the weight of her full leg. And a lot of this is mixed media. So 3D printing is a or the major component of it, but then we do work in magnets. Occasionally we work in metal, fabrics, glues, all kinds of different stuff depending on what it takes to make the device.
This is fascinating to me, not having much experience with 3D printing and having absolutely no experience with, magnets and the metals and AT. But just hearing you list these types of products, these types of devices and their applications seems like it's a wonderful way to customize a piece of technology to help someone really perform their most meaningful occupations and express themselves through, music, art, or, just doing what they need to do through the day. What are some of the ways that you have seen 3D printing being able to address kind of the challenges in patient care that traditional methods might not fully address?
So like I said, 3D printing is really just one medium. And a lot of times there might be other approaches that are able to address what your client needs, whether those are around assistive technology or not. But where 3D printing really helps is where you need a specific shape of a device that's going to meet the specific needs of your client that they can't get from something that's already available off the shelf. So a lot of times I tell folks, if you can find the thing you need from your online big box retailer of choice and they can get it to you in 2 days at no shipping cost, that's probably a better way to go. But the phrase I use a lot is one size fits all means it's not perfect for anyone. So if you try that and it doesn't work and the person needs something a little bit more specific to them, that's where the benefits of 3D printing really come in. And then it also gives you the ability to try to build some economies of scale by, once you have a device that works for one person, saving your design process, and then being able to tweak it for other people in the future. So I think it's really just about filling those gaps where an existing device doesn't already do the job.
It sounds like 3D printing can be such a wonderful application and method of assistive tech, in that it has that kind of customizable aspect to it, and like you've mentioned, can be replicated, saved, and designs can be tweaked and used differently on a case by case basis. How do you approach kind of demystifying 3D printing? Because it does have all these, advantages, but is also unfamiliar for a lot of people, and maybe even intimidating for those who are unfamiliar with the technology. Are there common misconceptions or additional details you'd like to share with our listeners today?
So yeah, I understand that 3D printing can seem intimidating. It's this big, bulky device that has electrical components, computerized components, mechanical components. But at the end of the day, if you understand 3 basic technologies, you already know how this works. And those are a hot glue gun, an Etch-a-Sketch, and to a lesser extent, an elevator, or even just a stack of printer paper. So a hot glue gun is nothing terribly intimidating, right? You pull a trigger, a gear turns inside and pushes a piece of thermoplastic through a hot tip that melts it to a liquid. And then when it cools back to room temperature, it retains its shape. This is not different from splint material that most OT practitioners are already familiar with. So as long as you understand that squeezing the trigger turns gear, pushes solid through a hot end into liquid, you're set. And Etch-a-Sketch, you turn one dial, it moves your cursor in the X direction, let's say left to right. You turn the other dial, it moves it in the Y direction, front to back. And you use the combinations of those 2 dials to move your cursor side to side, front to back, to draw a 2-dimensional image. And then I think elevator sounds a little intimidating. By that, all I mean is think of an elevator that has to stop at every floor from the ground level of a building all the way to the top. So your hot glue gun is mounted on an Etch-a-Sketch cursor, moving side to side, melting plastic, laying down a 2-dimensional image, and then it moves up one floor of the elevator to lay down a second 2-dimensional layer on top, and continues going at heights of a fraction of a millimeter. That's why maybe the better comparison than an elevator is a stack of printer paper, because we're talking about a lot of really fine 2-dimensional layers stacked on top of each other that, again, once they reach back to room temperature, have this 3-dimensional object standing there. And the design is the other kind of scary part of this. How do I come up with a CAD design of a 3D printable thing? That's also a lot easier than you might think. Yes, there are big, expensive, industrial, commercial engineering CAD tools out there. You can learn to use those. They're not terribly difficult if you have the time. I don't have the time, Matt, and all I have ever learned to use well is a product intended for junior high students, middle school students, called Tinkercad. It's a free online platform made by the same people that make one of the big major industrial CAD programs out there. And it takes a geometric design process where you learn to just combine simple shapes. It's very easy. Anyone can do it. I have taught grade schoolers to use this. Dory Zakin, an OT at the Boston Collegiate Charter School, did a really neat presentation at ATIA, the Assistive Technology Industry Association conference this year, where she encouraged participants to bring their laptop and in the course of a 1-hour session taught people how to do CAD design in Tinkercad to make AT. It's really not difficult. Once you get more into it, there are some nuances you have to learn about how you set up your geometry to make it print successfully. But you have one failed print and you'll learn those things really quickly. It's really a very simple process if you just have the willingness to jump in and try it.
I love that. Thank you so much for that explanation. It really breaks things down in terms of how the 3D printer works and how these, applications or supports can work. A follow-up with the process. So is the typical process of creating AT where a practitioner would download a design from, a service like you've mentioned, Makers Making Change, and then edit that design in a software like a Tinkercad, and then from there print it out? Or how does that step in the process work?
Yeah, there are a couple of ways that can go. One, much like looking for an off-the-shelf option, you may find through Makers Making Change or on Thingiverse that there is a design that's going to meet your client's needs right away, or you think might be close and you want to test it first before you start tweaking with it. I'll make a comparison here to cooking or baking, right? You don't want to start tweaking your recipe before you know if it's going to work. So you try that device. If it doesn't work, you figure out why along with your client, talk through what's comfortable and what works for them or what doesn't. And then, yes, you can turn around and take that file right into Tinkercad and start tweaking it right there on the computer screen with your client. It is that simple. And then you take that rapid prototyping approach, print it out again, try it again until you land on something that works.
I love that. I love that, Bill. You've mentioned already exploring the intersection of the engineering design process and the OT process with the PEOP framework. I want to ask again, how does this perspective help enhance collaboration and outcomes?
Yeah, so like I said before, we have our own complementary skill sets and kind of theoretical bases for how we work. And I think about this through PEOP. I bet you could take most, if not all, other OT models and come to a similar conclusion here. But there's a really clear overlap between how the OT process works through a PEOP lens and the engineering design process. So engineers have their own formal process and designers have their own formal process for how they come up with a new device. The language of it varies a little depending on who teaches it, which textbook you look at. But it's basically a cycle where you start by defining the user of your device, defining the problem that you're trying to solve, creating a design for that. And by creating here, I just mean even doodling or drawing something, creating a prototype, testing and analyzing that prototype, and then iterating and redesigning. And then you go back through looking at the definition of the problem. So that process of defining the user and defining the problem sounds a lot to me like understanding the person and understanding the mismatch between the person, their occupation, and their environment. That is the problem, that mismatch that gets us to occupational performance. So if you overlay those two models on top of each other, you have a great opportunity to bring in all of the OT expertise and engineering expertise to come up with a better design that meets the person's needs. So to put that in practical means, that means for me sitting down with an engineer or sitting down with an engineering student and your client all at the same time and talking through the issue, because you're going to find that you as an OT practitioner and your engineer or designer companion are going to ask different questions. And that has really expanded my thinking to AT and even the OT process by hearing their perspectives. And they tend to get a better, more holistic understanding of what your client needs in the process.
I love that. And I'm glad you mentioned that piece of sitting down, not just with a designer and engineer, but having the client there as well.
Absolutely.
In what ways have you seen involving clients in the customization process impact their outcomes and their engagement with whatever AT device is being developed?
Yeah, so it's a process we call co-design, and you'll find examples of co-design throughout engineering and design and AT design. Co-design means including the end user of whatever device as a member of the design team. And who is better at defining the user and defining the problem than the user who has the problem or the issue that they're trying to work on? I can sit here and try to define it all day long, but I cannot define it even as an OT as well as the person who's trying to do the task. So you get really great input from the individual who's going to potentially be using the device who needs to be doing the task. And I'll tell you, it's humbling and can even be frustrating when I think as an OT with plenty of experience doing task analysis and designing OT, there are plenty of times I think I know the right answer. And the first time I propose it, the end user shuts it down right away. And 99 times out of 100, I have to say, oh, they're right. There's some other aspect of this I have not considered. 1% of the time, we're all a little stubborn, right? And want things a certain way. So I may advocate for an idea or at least trying something, but that user perspective is pretty much always right.
I love that. That's a great tip for our listeners as well. No matter your practice setting or approach, or whether you're using assistive technology or not, including the client in that decision-making process and the planning process of selecting interventions and achieving best outcomes is so important. Bill, I want to thank you again. You shared some of your research and some papers that I reviewed in preparation for our interview. I wanted to ask about some insights from one of those publications, the Rasmussen 2022 project that was carried out in your local ALS clinic, where customized assistive technology solutions were developed. How did that experience and that study specifically really shape your approach to using assistive technology in care?
Oh, thanks. Yeah, that was a really fun one and kind of started us down this trajectory. The Rasmussen in question here is Kyle Ann Rasmussen. She's now on faculty at Texas Women's University. She was an OT student here at the time, along with the other co-author on that paper, Brianna Perry, now Stewart, who is a graduate of our program as well. That project was really the result of a bit of serendipity. The ALS clinic here at the time did not have an OT for a brief period and needed someone to fill in. I was available to help with that and came in with this AT mindset, which is what that role generally was previously. And we very quickly came to realize that there were these unmet needs. In case your listeners don't know, ALS, or amyotrophic lateral sclerosis, is a progressive, universally fatal neurodegenerative condition. And so the AT focus there, rightly, tends to be on some of the higher order needs that people have around communication access, primarily. But there, as a result, there isn't much focus on these lower level, earlier needs, like for daily assist devices. So what we learned early on was there were these unmet needs, but not only were the needs not being met, they weren't even always recognized by the providers or even the clients themselves. So I think the big insight we got from that, and this isn't what we talk about in the paper as the primary insight, but what we really got from it was asking folks, what is it that you're having difficulty in your daily life with, was not giving us useful answers. And even taking kind of a COPM approach of trying to prioritize people's tasks wasn't giving us useful information when it came to the individual needs that folks had. What really helped us there was learning to ask, what is it your spouse has to do for you in the morning? Or how did you get dressed this morning? That what do you get help with question, I think, is what helps people to identify potential areas to work on, because it's so natural to move into having assistance. And to be clear, in many cases, assistance is the right answer. We don't need to prioritize independence over everything else. But that question of what did someone help you with is what opened the door to, oh, I can no longer tie my own shoes or fasten a bra or these things that are taken for granted so much of the time. And I just assume now for the rest of my life, I have to have someone help me with it. I didn't even consider that there was an opportunity for doing it a different way. And so learning to change that question and start the conversation with folks really opened the door to all of these little daily needs that we all have, and we might have different ways of trying to address.
That's beautiful. The way you frame that question and in having a conversation about those topics that so many people don't consider, that I can see how that can be so impactful and lead to some really creative and collaborative applications of assistive technology, and in some cases the use of 3D printing to solve some of those problems and restore or maintain some level of independence in those tasks.
And if I could jump in there too to follow up on that, it's particularly important, and 3D printing can be a good medium specifically in the context of ALS, with it being such an unevenly progressive condition. We would have folks who are seen quarterly, and so we do essentially an evaluation, and then they come back 3 months later and the picture is completely changed. So the rapid prototyping becomes really important. And 3D printing gives us the opportunity to produce new devices much faster than if we had to send them out for manufacturing somewhere.
Yeah. I love that. Another advantage of 3D printing. We've been able to highlight a number of those. One being this rapid production of tech as needed, adaptability, replicability, and accessibility. I wanted to ask some follow-up questions related to another paper you sent. This one was cited as Howard 2022, and outlines the true costs behind bespoke AT devices, which factors in personnel time for design, production, and what's called post-processing. How would you say that the findings in this publication shifted perspectives on the accessibility of 3D printed solutions?
Oh boy. Yeah, that paper, Jonathan Howard was working on his PhD at the time, I believe, over in the UK. I had nothing to do with this work other than when it came across our desk, Kylan Rasmussen and I both read this, and it was kind of a revelation because it addressed this issue that we knew was out there. But I think if 3D printing for AT lasts and is more than just a fad, that paper is going to be remembered as kind of a landmark or a turning point. He really did change how folks think about the cost of these devices. Every paper you read before Jonathan's paper came out, and most since then, to be candid, will talk about how inexpensive 3D printing is. We made a device for $1.50 that would have cost $20 had we bought some comparable off-the-shelf device. That's all well and good, but those all focus on the material cost. The cost of the plastic filament is very inexpensive. But if you think of most of the little 3D printed, or I'm sorry, not even 3D printed, if you think of most of the little plastic things you have around your office or your home, the actual plastic that went into those was a negligible expense. It's the labor, it's the equipment that goes into making the thing, it's the design time, and to an extent, there's a profit margin built into those too. But people talk about 3D printing as if it's this route to super affordable, super inexpensive devices, assistive technologies or otherwise, when in reality, they're only looking at material cost and ignoring all of these other factors. So that paper did a really nice job of, I think for the first time, incorporating not just material cost, but the design time, manufacture time, shipping, to reveal the true cost of what they called, and we have now adopted the term, a bespoke AT device that is often in the range of $100 or more for what gets reported elsewhere as like a $1 or $2 device. That doesn't mean that 3D printing is not valuable or even cost effective, but not in the way people have thought about it for the last 20 or 30 years.
How do you begin to balance kind of the increased cost of customization with the potential benefit for clients?
That's a great question, and we're still coming to grips with it. Like everything else in OT, the answer is it depends. So, like I said before, if there is an off-the-shelf device from your retailer of choice that will do the trick, it's under $10 and you can get it in 2 days, go for it. Buy the device. It's probably been well designed, well tested. They've had user feedback, and it may well meet the needs. But if that device doesn't meet the need of your user, it's just a waste. And that's where we have all of this past literature of AT devices that wind up collecting dust in a closet, right? If it doesn't meet needs, then you need to explore opportunities to either modify the thing they have or make something new. And then again, as I said before, you want to look toward ensuring repeatability, replicability of your device going forward. And I encourage people to take any device that you've designed and make the design open source. I don't fault anyone who has an entrepreneurial bent to them and wants to try to sell a thing. If you can, great. If that's not your goal, make it available to the world. And then you can take more advantage of that kind of economy of scale so that your one-off device that has all of this investment in design time doesn't just get limited to benefiting one person. So you haven't put in dozens of hours and hundreds or thousands of dollars of design work into a device for one person. You put all of that toward future devices so that they approach that affordability and efficiency over the long haul.
I love that. And that's such an interesting aspect of 3D printing and assistive technology on its own, is this potential to develop a massive open source library of devices that could be downloaded, that could be used, and could really just increase the reach and impact that OT approaches and applications using assistive tech could have.
We'll get back to our interview right after this quick message. You all know we really try to make research more consumable and applicable on everyday evidence. But did you know that just 1 minute of your time could help us to improve the show, improve the resources the American Occupational Therapy Association provides for practitioners, and improve the application of evidence to practice within our whole field? Please take our 1-minute survey. It's only 3 questions, and you can find the link in this and every episode's description. And support the AOTA in continued efforts to improve our podcasts and to improve the translation of research to practice. Now back to the interview.
I wanted to ask about one more paper. This was cited as the Benham 2025 paper that was recently published in the Occupational Therapy Journal of Research, and contains some practical suggestions for clinicians and educators interested in exploring 3D printing. Could you speak to some of those?
Yeah, so that effort was led by Sarah Benham, and there's a whole group of us that are OTs that do 3D printing in our own clinical and research kind of work, where we came together to think about where does this go from here. A lot of what I've already said applies about thinking about when 3D printing may or may not be a good approach for you. And our main goal there is to remind people to keep your goal in mind, that client-centered outcomes are really the key and focus of what you need to be measuring to ensure what you're doing has some benefit. We also encourage folks to remember their scope of practice. So it can be really alluring once you know how to 3D print, once you know how to make these physical things, to make everything. And I got to tell you, there are some things that we have no business trying to make. Again, that's part of our kind of personal commitment to stick to those class 1 daily assist devices. But there have been instances of some folks, not in OT, I should say, trying to 3D print crutch tips, which for a lot of reasons is a terrible idea. you may only spend a couple of dollars on the material costs, but as Ken Hackbarth, a designer, has pointed out, you're risking hundreds of thousands of dollars in medical bills if you get someone hurt. So we recommend, while you're keeping in mind your scope, sort of a tiered approach. Start with those free online tools and tutorials. Use something like Tinkercad to just play and see what you can come up with, even if it's silly. Use YouTube to find videos of people showing you how to do some of this design work and to share their ideas. Attend conferences to see what other folks have made. And then before taking the jump, taking the leap and spending the money on a 3D printer, I would encourage you to seek out someone that has one locally. There is probably a makerspace, either as a standalone entity or at a local middle school or even at your local library, where you can go check this out. Try printing a design of your own and see if it's going to be a good fit for you. There was a piece of advice I read years ago. I'm not sure. It might have been from Adam Savage's book from Mythbusters fame, for those of you that remember that.
Yeah, it's such a good
advice. I know. The advice was to basically spend as little as possible on the first version of any tool that you think you might use. So his recommendation was buy the Harbor Freight version of something first, see if it's going to fit into your workflow, and then decide whether it's something you want to invest in. And if so, invest in it. Give it the kind of weight that it deserves. So I suggest, again, use someone else's 3D printer first. Consider buying the least expensive one you can for somewhere between $100 and $300. See if that's going to work for you. And if you realize, yes, this is something I have the skill set to do, I'm willing to give it the time that it needs to do this well, then spend a bit more or convince your employer to spend a bit more on the larger, more capable machine. But I wouldn't make that investment until you know it's something you want to stick with, because it does take a lot of effort and a lot of work to keep it all going.
Those are wonderful recommendations, and I love that recommended approach to the process of designing and potentially printing a new device for a client. What skills or knowledge would you recommend that practitioners develop to help them integrate 3D printing into their practice, if appropriate?
Yeah, I think the first one is still that core of OT, which is task analysis, right? You need to be able to, either through talking with someone about what they're doing or through observation, understand the task that the person is trying to do and what the deficits are or the issues that you might be trying to overcome. So really hone your task analysis skills. You're probably better at it than you realize you are, because we tend to do it without thinking in OT. And then again, start with those free, easy to use CAD programs. I mentioned the talk that Dory did at ATIA this past year. She had people just start by designing a little house in Tinkercad, something really simple where you take a cube and a pyramid, stack them on top of each other. We know from the educational technology literature and even industrial psychology that the best predictor of whether someone is going to adopt a new piece of technology isn't age, which people have thought historically it was. Age is really a poor proxy for playfulness. So your willingness to just get in there and try and be willing to make mistakes and learn from those mistakes is really important. So start with low stakes, just trying to make something on your own before you even try to make something for a client, to test out what you can do and learn some new things. And then, like I said before, when it comes time to actually print your thing, you do have to know some basic things about the geometry of what you're trying to print, the parameters that have to be entered into your printer. And you can learn a lot about that online, again, from YouTube or from some social media platforms, or better yet, go to your local makerspace and you're going to be surrounded by nerds like me who want to help you learn to do these things. So start with the easy stuff and just get some practice at it, and it comes pretty easily from there.
I love that. Those are wonderful recommendations to bring that playful attitude, that willingness to explore and ask for help And I love to quote the phrase "successfully fail." That's how a great recommendation for approaching this. Bill, could you share a case example from your own practice or something you've seen where a 3D printed solution made a significant impact on a client's daily life?
Oh, boy. Yeah, it's going to be hard to narrow it down to one. There are two that really taught two different lessons. Both were women that have ALS. One was in her early 50s, and when we asked that question of what do you need help with, what does somebody help you do in the morning to get ready, her answer was squeezing toothpaste out of the tube. So I mentioned before finding a toothpaste tube roller design that existed already on Thingiverse. Our students printed that out, and the woman tried it and said, hey, this is a great idea. I like this idea. It doesn't quite fit in my hand. I can't quite get the torque on it I need to turn this thing. And so they sat and talked with her for a while, came up with some alternate designs for how to tweak the existing thing, printed a new version, and she loved it and liked it so much, in fact, that she said, hey, this is great for toothpaste, but I'm also using a hair gel that comes in a plastic tube, very similar to toothpaste, but bigger. Can we scale this up? And sure enough, those same students were able to take that design, scale it up, take all of their OT knowledge and their burgeoning CAD knowledge to make a new version of a thing that didn't exist before. And she wound up liking both of them so much, she asked for duplicates for her home, her partner's home, to take on vacation. So we wound up making a whole bunch of those and have since provided them to other folks. And the other, to your point of failing successfully, I think one of the most rewarding instances we had was a woman for whom we made a device that did not work at all, but it opened up some new opportunities. So this was another woman, in this case in her late 30s, I believe, with ALS. An onset that early is not super common, and it can be pretty devastating, especially when you have a young child at home. And she was now struggling with putting her daughter's hair in a ponytail. It was a thing they did every morning, and now she didn't have the finger dexterity to do it. So we talked with her for a bit and came up with an idea similar to the Topsy Tail. If you remember the commercials from the 90s, and I gather this is still a product that exists, where we designed a little plastic 3D printable J hook that she could kind of loop her daughter's hair through along with her hand to try to put it in a ponytail. So we make this thing, she takes it home, and she tries it and comes back to us and says, hey, this did not work for me at all. We had sat down with her and kind of practiced and tried some things, and she said, this just does not meet my needs at all. But it opened my eyes to the idea that there are other ways of doing this thing that I wanted to do. What we as OTs were taking for granted, this task analysis thing and this shifting the locus of the problem from the person to the environment or the task, it opened up to her like, hey, there are totally different ways I can try to hold my daughter's hair. There are other things sitting around my house. So I've tried 2 or 3 different things, and I found a way that I can do this every day that is no additional difficulty for me, doesn't cause me to waste any energy, it doesn't hurt, and my daughter is satisfied with the outcome. And I wouldn't have thought to do those things if we hadn't tried this device. So we failed. The outcome was totally successful. And that was just as rewarding as coming up with a device that would have done the trick for her.
I love that. Thank you, Bill. Those are wonderful examples of the impact that OTs can have. And so much is having this willingness to experiment and try different things and empower our clients to explore and find what works the best for them. So I love those examples. Thank you for sharing those. You're currently doing an ongoing project that's funded by the ALS Association regarding customizable assistive technology. What additional trends or outcomes are emerging from this study?
Yeah, so we're still working through the analysis on that, and we're not quite ready to unleash it on the world. But I will say it has been our first opportunity to really take those lessons from Jonathan Howard's work and to look at more how we can make this an economically sustainable approach. If AT devices are entirely dependent on our continued grant funding, then they're not doing anyone any good once that grant is over. So it's helping us to define the economics of these devices a bit better. We've been able to cover a 3-state area of ALS Association chapters where we work with providers and end users to come up with devices for them. It's also taught us a lot about these kind of design questions and perspectives that I mentioned. It's helped us to realize that, oh yeah, these aren't necessarily the ways every OT practitioner thinks. And so we need to help not just individuals think through what might be possible, but have that what does your spouse have to do for you in the morning conversation with therapists to help them with their AT evaluation process as part of their OT evaluation process. So I think those are going to be the big things that come out of it, is just helping us to help people, both users and practitioners, realize what's possible to help them bridge those gaps.
I love that. It's very exciting. You are doing excellent work. Thank you for sharing it with us here. And we'd love to revisit, some of those outcomes when you are ready to unleash this to the world, and hopefully encourage other practitioners to do the same. What types of research do you believe are needed to solidify the role of 3D printing as an approach within OT practice?
Oh boy, so much. I mentioned before all of this previous work on 3D printing for AT that has focused on the low material cost without addressing all of the other issues of cost. Part of that comes from a systematic review that Kyle and Dr. Rasmussen and I are putting together that is under review right now, and we hope to have out soon, that tells us there is just a glut of papers out there about these really hyper-local feasibility projects and one-off device design projects that all show positive results in admittedly really biased samples. And it basically confirms that if you do the co-design approach well enough, you're going to come up with a device that works for one person. But that doesn't mean it's going to be sustainable or can be replicated elsewhere. So I think we need to move from these hyper-local, one-off design approaches to actual clinical trials. We need to move from this not even stage 0 work into looking at efficacy of either the designs themselves or the design approach, and then on to things like effectiveness. We know that devices can be co-designed. We know they can be printed. That work is no longer useful. We're not adding anything to the body of knowledge if we do those studies again. We need to know if they're actually beneficial. There's been some work out there, a limited subset, that use things like the QUEST, the Quebec User Evaluation of Satisfaction with Technology, or the PIADS, looking at psychosocial impacts. There's been very limited work, even at that level, saying, are people satisfied with these devices? We need to really hit that hard and move on to, is it making a meaningful, measurable impact on people's lives? And part of that, I think, is going to be driven by where we think 3D printing or otherwise making assistive technology needs to live long term. So OTs aren't the only ones interested in this. Engineers and designers aren't the only ones interested in this. Hobbyists are really the people who make the most 3D printable stuff. And when we think about like the school context, it's not just your OTs, it's your paraprofessionals and your teachers who are making devices for kids in school districts. So we need to think about, is this an approach that lives in, say, the fee-for-service medical model, or is it really better off belonging to the hobbyists and they get included in the process when we want to make things? I don't know the answers to those, Matt. I don't know where this lives long term, but I think that drives the kinds of questions we need to ask because the efficacy and eventually the effectiveness may depend on who's doing the work, and the level of rigor needed in the research is really going to depend on whether we think this is something that's going to be billable as a medical service or just something people are doing out of the kindness of their hearts. That's what we've got to figure out next.
That's a big ask and an exciting ask to investigate and problem solve and workshop. What resources, funding opportunities, or communities would you recommend to listeners, OT practitioners who are interested in exploring this field and learning more about what we've discussed today?
Yeah, so, for funding that kind of large-scale research side of it, NIH, call me, I'm ready. But for individuals kind of wanting to implement this, I really have to say, start with Makers Making Change. To give you an idea of what's available, there are so many free resources there, both in terms of designs and even instruction for how to start making stuff, that's your best place to start. Again, go to a makerspace. It's an inexpensive, oftentimes free way to start getting hands-on with this technology and to learn from people who can teach you these things. Attend conferences. There are always a couple of sessions at AOTA each year at the Inspire conference about 3D printing. ATIA, I mentioned before, the Assistive Technology Industry Association, and RESNA, the Rehabilitation Engineering Society of North America, have both really great resources and communities around making devices. I would generally say stay away from social media. Those environments tend to be flooded by new users looking for advice that are just as confused as you are. And then people who have been doing it for a long time whose answers may verge on the toxic of forgetting why people might not know these things. Although there are some communities of like OTs in 3D printing that you can find that are pretty helpful. I would say look to your state AT Act program. AT for New Jersey and Missouri AT collaborate on a monthly maker roundtable where people get together, not just OTs, but folks from all kinds of different disciplines and programs who are all about making AT. We get together monthly and just talk through our design problems and ideas and help each other brainstorm new approaches and solutions. And then as far as funding these things, look for nonprofits that are local to you or specific to the conditions that you're interested in. Again, the ALS Association has been a big help with our research because we're working specifically with people with ALS. There's an organization here in Missouri called the Mo Better Foundation, Mo being short for Missouri, but also meaning more, that is entirely focused on helping people with physical disabilities to be more engaged and able to participate in their daily lives. And they love funding work like this, whether that's to help people get started in making AT or in helping to pay for people to acquire their own devices. So look for those local nonprofits whose interests align with your own. And 3D printing is such an inexpensive thing to get started in. It's not a big ask a lot of times to ask for a printer and a couple of spools of filament to get you started.
I love that. Thank you for those recommendations, Bill. How could our listeners connect with you or learn more about your work specifically?
Sure. So most of what we do winds up in one form or another on our website, which is atatlab.missouri.edu. That's short for Assistive Technology Adaptation and Training. So atatlab.missouri.edu. Again, has links to pretty much everything we're doing in the lab.
And a follow-up there, do you have a 3D printed model of a Star Wars AT-AT in your lab?
That's always how I know whether people are on my nerdy level, as whether they understand the origin of that acronym. I do not have a 3D printed one in the lab, but there are pictures of them all over the place and hidden somewhere in most of the presentations that I give.
I love that. It sounds like a rad lab. I want to end with our golden nugget segment, Bill, and just ask you one final question. If there was one piece of advice or one recommendation that you could give to our listeners, what would you say?
Play. Try. This is the type of thing that, again, seems intimidating until you just give it a shot. And we know from all of the literature on using new devices and technologies that just your willingness to play is the most important thing. Try and then look for people who can help you. Go to my lab website, shoot me an email. I will gladly talk you through whatever issues you're having or find someone locally who can do that. And as long as you're just willing to play and try, I promise it is a relatively accessible, easy to use approach that you might find beneficial. And you start learning a lot more and seeing a lot more opportunities once you understand how the tool works.
Absolutely. Well, Bill, thank you again so much for your time. It's been an honor to meet with you, to learn from you, and thank you for sharing all these recommendations today.
Thank you, Matt. I've really enjoyed it.
Thanks for listening to Everyday Evidence. Tune in next time for more evidence-based practice insights and applications.